Hi kids, in this video we'll discuss theorems on area from class 9 ML Aggarwal. This is lecture 1 where we'll discuss all the theorems, because before doing the sums, if you know the theorems properly, it becomes easy. Okay, now before moving to the first theorem, I need to tell you about two axioms on area. First is congruence area axiom. What does it state? Suppose you have two triangles ABC and you have PQR and they are congruent. Triangle ABC is congruent to triangle PQR. Then, according to congruence area axiom, area of triangle ABC will be equal to area of triangle PQR. If two triangles are if two triangles are congruent, then the areas are same. Done? The first one. Second one. Addition area axiom, which is very simple. Suppose you have a planar region R which consists of two non-overlapping planar region R1 and R2. Then the area of R will be sum of area of R1 and R2. Area of R1 plus area of R2. This is quite logical. Okay. Now, one more thing we need to know. When do you call figures as equal figures? Equal figures. When two figures have same area, figures having same area is known as equal figures, which means all the triangles which are congruent, they are equal figures because the areas are same. We know that. But there can be case that the two triangles are not congruent but they are equal figures. How? Just look. We take a right angle triangle A, B, C. This is suppose 6 centimeter. This is 2 centimeter. Then area will be what? Half into base into height. That's 6 centimeter square. Done. Take another triangle, right angle triangle, whose suppose this is 4 centimeter and this is 3 centimeter. Now find the area. A2. Again, half into base into height. That is 6 centimeter square. See, these two are not congruent, but the areas are equal, which means these two are equal figures. Which means all equal figures are not congruent. They are not congruent. Not congruent. But they are equal figures. Understand? Chalo. Now we look at the first theorem. Now let us look at the first theorem. It says that the diagonal of a parallelogram divides it into two triangles having equal area. What do I mean by this? Just see this diagram. Suppose you have this parallelogram A, B, C, D, and suppose this is one of the diagonal AC. Then AC divides this entire parallelogram into two triangles with equal area, which means area of triangle ABC is equal to area of triangle ADC. Now how do we prove that? Just look at this. If you look at these two triangles, triangle ABC and triangle ADC. ADC. First of all, AC is equal to AC, that's common. AC equals to AC, that's common. AD is equal to BC. We know in a parallelogram the opposite sides are equal. AD is equal to BC, opposite side of a parallelogram. Similarly, AB is equal to DC. ADC equals to AB. For one triangle, I'm writing it over here. For the other triangle, on the right side. Okay. So DC equals to AB. Again, same reason. Opposite sides of a parallelogram, they have to be equal. Which means these two triangles are congruent, isn't it? Side, side, side. Which means triangle ABC is congruent to triangle ADC by side, side, side axiom. And if two triangles are congruent, then the areas are equal, which simply implies area of triangle ABC is equal to area of triangle ADC. And that's your first theorem, that the diagonal divides the parallelogram into two triangles having equal area. Done. Now let us look at the next theorem. Now look at the next theorem. 2. Parallelograms having same base and between same parallels have equal area, which means if there are two parallelograms which have the same base and they are between the same parallels, then the areas will be also equal. Just let us draw the diagram. Suppose we have a parallelogram, just look over here, A, B, C, D. What I do, I'll just extend DC or CD and I'll draw another parallelogram, whose base is still AB, ABED. Now look carefully. ABCD and ABED have the same base and they are between the same parallels AB and DC. Then their areas are equal. The theorem is area of ABCD is equal to area of EF. This is F. ABEF. How come? Just look over here. We'll try to prove this. Now, look at these two triangles, ADF and BCE. Triangle ADF and triangle BCE. First thing, AD and BC will be same, isn't it? AD equals to BC, opposite side of a parallelogram. So they have to be equal, isn't it? Next, if you look carefully, this angle and this angle are same, they are corresponding. Because these two are parallel. This is parallel to this. This is parallel to this. This is parallel to this. So these two are parallel, isn't it? This is a transversal. So this angle and this angle are corresponding. So I can write ADF. Angle ADF is equal to angle BCE. Corresponding angle. In the same fashion, this angle and this angle are equal. Corresponding again. Because these two are parallel, this is a transversal, okay? Angle AFD is equal to angle BEC, again corresponding angle, which means these two triangles are congruent. Angle side, triangle ADF is congruent to triangle BCE, angle side. Now if these two triangles are congruent, then the areas are equal. Which means, can I write area of ADF, just look carefully, is equal to area of BEC or BCE, whatever. The areas will be same, this area and this area will be same. Now what I'll do, On both sides, I'll add this region A, B, E, D. I can do so. Same quantity. So area of ADF plus area of ABED, area of ABED is equal to area of BEC plus again area of ABED. I've added this portion to both the triangles area. Now area of ADF plus ABED is nothing but the parallelogram ABED. Look carefully, which means area of parallelogram ABEF is equal to, and this side area of BCE plus this area. When you combine these two area, it becomes area of ABCD. Area of parallelogram ABCD. Done. This is what we were supposed to prove. That if there are two parallelograms having the same base and between the same parallels, then their areas are equal. Done. Now based on the theorem which we discussed, that parallelograms of the same base and between the same parallel lines or parallels are equal in area, we have three results. The first one, a parallelogram and a rectangle on the same base and between the same parallel lines are equal in area. Very easy. Again, same thing. If you suppose have a parallelogram, A, B, C, D, and with AB as the base, suppose I draw a rectangle, ABEF, then area of ABCD is equal to area of ABEF. That's quite obvious. Why? Because ABEF is a rectangle and rectangle is a parallelogram, which means these two are parallelograms having the same base between the same parallels, which means area has to be equal, isn't it? Just since ABEF is a parallelogram, rectangle is a parallelogram, okay, then the area will be equal. So area of parallelogram ABCD will be equal to area of rectangle ABEF in this particular case. Yes or no? This was similar to this only. Okay, because we know ABEF, which is a rectangle over here, is also a parallelogram. Rectangle is also a parallelogram. Okay. Then number 2, area of a parallelogram is base into height. Now look carefully. Just now we got area of a parallelogram ABCD is equal to area of rectangle ABEF. Now area of ABEF is length into breadth, which is BE. Now if you look carefully, for the parallelogram ABCD, AB is the base and BE, since from this vertex it is perpendicular, on CD. So BE is the height or the altitude. So base into height. For the parallelogram, BE is the height. Yes or no? So area of a parallelogram is base into height. Remember that. Now let us see the third one. Parallelograms with equal base and between same parallels are equal in area. See the theorem. Over here it was same base, equal base. Look, I'll draw the diagram. Suppose we have a parallelogram ABCD with an equal base and between the same parallel, which means suppose I extend this, okay, this is suppose EF, suppose here EF, okay, and I'll draw another parallelogram, see EF GH. such that EF is equal to AB. So what happened? Here I have drawn two parallelograms A, B, C, D, E, F, G, H, and they have this equal base and they're between the same parallels EB and HC. Then the areas will be equal. How do you prove that? Just look over here. We need to prove that area of ABCD is equal to area of EFGH. What do we do? First, let us draw a perpendicular EM. Okay, and let us draw another perpendicular. Suppose BN. Okay, EM and BN are perpendiculars on HC, which means EBNM will be a rectangle because these two are parallel. So this is 90, this is 90, of course. So this is a rectangle. EBNM is a rectangle. So if it's a rectangle, then EM will be equal to BN. EM will be equal to BN. Now look carefully. If I write area of ABCD, just look carefully at the diagram. Area of ABCD is base, which is AB, into height, which is BN. Now, instead of AB, can I write EF? Of course. Instead of BN, can I write EM? Of course. Instead of BN, I've written EM. It's a rectangle, opposite sides are equal. Now look carefully. For a parallelogram EFGH, area will be base EF into height, which is EF into EM. So this is nothing but area of EFGH, which means both the areas are same, isn't it? Both the parallelograms are the same area. They have equal base, not same base. Same base is something else. Same base, equal base, and between same parallels. Done. Now let us see the converse. So the converse of the theorem which we discussed is also true. In fact, we have the theorem that parallelograms having same base and area are between same parallel lines. What do I mean by this? Just look over here. Suppose I have a parallelogram A, B, C, D. With the same base, I draw another parallelogram A, B, suppose E, F, and area of A, B, C, D is equal to area of A, B, E, F. This is given to us. Then we need to prove that AB is parallel to FC. AB is parallel to FC. Just look. Now, what I'll do, I'll drop a perpendicular DM and EN on AB. Now, DM and EN are perpendicular on AB. Just look carefully. What we have written? Area of ABCD. Now, area of ABCD is equal to base, which is AB, into height. AB into height is EN. Yes or no? And area of ABEF. Okay. Instead of EN, we can write DM. Yeah, that's the height. Now, from the vertex on the base. Now, for the parallelogram ABEF, again, base, which is AB, into height, which is EN. Yes or no? AB cancels out, which means DM equals to EN. dm equals to en. Now dm and en are perpendiculars on the same line AB, which means these two will be parallel and they are equal. So if these two are parallel and equal, we can easily say that MNED is a parallelogram. We know this. If one pair of opposite sides are equal and parallel, then it's a parallelogram. Now, if it is a parallelogram, can I say that MN is parallel to DE? Yes or no? Yes. Which means AB is parallel to FC. Proved. So we have two parallelograms having the same base and equal area lie between the same parallels AB and FC. Okay. Now based on this also we have some corollary. Let us check out those. Now based on this theorem which we just did now, that parallelograms having same base and area are between the same parallels, we have two outcomes. The first one, parallelograms on equal base, same has been replaced by equal base, and having equal areas have equal corresponding altitudes. Okay, and number two is parallelograms on equal base and having equal areas lie between same parallel lines, which means the first one, if you look, that if I draw a parallelogram A, B, C, D, and if I draw another parallelogram E, F, G, H, and EF equals to AB, equal base and having equal area, then they have corresponding, then the corresponding altitude, if this altitude, the height, for both the parallelograms, the altitude will be same. That is G, suppose this is G, I and B, M. G, I and B, M will be same. Done? And parallelograms on equal base and having equal area lie between the same parallels, which means EB is parallel to HC. Okay. Now let us look at the next theorem, very important. Area of a triangle is equal to half the area of a parallelogram having same base and between same parallels, or parallel between same parallel lines. Just look, if I draw a parallelogram A, B, C, D, and suppose with AB as a base, I draw a triangle ABE, then area of ABE is half the area of ABCD. How come? Just look over here. What I'll do, I'll extend DC and I'll draw a line parallel to AE, BF. I'll draw BF parallel to AE, and this is already parallel to this, which means ABFE is a parallelogram. ABFE is a parallelogram. Now, in this parallelogram, EB is the diagonal, which means EB, we did the first theorem, EB divides this parallelogram into two triangles of equal area, which means area of ABE is equal to area of BFE, isn't it? The diagonal divides the parallelogram into two triangles having equal area, which means area of BFE, I can write area of ABFE, the parallelogram ABFE, by 2. It's been divided in two parts. So each part is the half of the parallelogram. Now look carefully. Area of ABFE and area of ABCD. Area of ABFE is equal to area of ABCD because they have the same base and they are between the same parallel lines. So instead of area of ABFE, can I write area of ABCD by 2? Which means area of the triangle is half the area of the parallelogram, having the same base and between the same parallels. Done. Now let us see certain results based on this theorem, okay? Now based on the above theorem, that is area of the triangle is half the area of the parallelogram on the same base and between the same parallel lines, we have number 1. Area of a triangle is half into base into corresponding height. How come? Just look over here. If I draw a triangle ABC and suppose AM is the height corresponding to the side BC, then area of this triangle will be half multiplied by base multiplied by corresponding height. How come? Just look over here. What I will do, through A, I'll write it over here, half into base into height. Through A, I'll draw a line parallel to BC, and through C, I'll draw a line parallel to AB. That is A, B, C, D, suppose. This is parallel to this and this is parallel to this. Then ABCD becomes a parallelogram. Now, area of ABCD, which is a parallelogram, is base into height, that is AM. Now we know by this theorem that area of triangle ABC will be half area of parallelogram ABCD, having the same base and between the same parallels, which is half into area of parallelogram ABCD is base into height AM, which means area of the triangle ABC is half into base into height, corresponding height. Done. Number 2. Number 2 is that in a triangle, the median divides the triangle into two parts or two triangles having equal area. What do I mean by this? Just look over here. Suppose we have this triangle ABC and suppose AM is the median. Median means M is the midpoint of BC. AM divides BC into two equal halves. Now what I do? So the area of ABM will be equal to AMC. That is the outcome. How? Just look over here. From A, I'll drop a perpendicular on BC or BM. Then area of ABM, look carefully, half into base into corresponding height, suppose AN, yes or no? And area of ABM over here. Area of ABM is half into base into height. Area of AMC, that's the other triangle, is half into MC, base, into height, which is AN. Now, BM and MC are equal. BN and MC are equal. So this I can write half into BM into AN. Look carefully. So this becomes area of ABM, which means area of ABM and area of AMC is same, which means the median divides the triangle into two triangles having equal area. Done. There is one more. I'll just rub this one, number 1. So look at the third one. That area of trapezium is half into sum of parallel sides into perpendicular distance between them, which means the altitude of the trapezium. look over here. I'll draw a trapezium A, B, C, D, and suppose Cm is the altitude or the height. This is perpendicular. I need to prove that area of this trapezium is half into AB plus CD into H. Let us see. What I'll do, I'll extend CD, and from A, I'll draw a perpendicular on CD extended part AN. Then AN and CM both are altitude for ABCD trapezium. This is parallel, which means if this is H, this is H. Now I'll join AC. Look at ADC. Look at ADC. Area of a triangle ADC is half into base into corresponding height, which is H. Similarly, if you look at area of triangle ABC, this again half into base into corresponding height, this is H. And if you add these two areas, this shaded portion, you get the trapezium. So area of trapezium will add these two, DC into H plus half into AB into H. You take half into H common, so DC plus AB, and DC and AB are parallel sides, isn't it? So area of trapezium is half into sum of parallel sides into perpendicular distance between them, which is the altitude, isn't it? Sure. Now let us look at the next theorem. Now let us look at the next theorem, that is triangles with the same base or equal base and between same parallel lines have equal area. What do I mean by this? Suppose this AB is parallel to this line L, and with base AB I draw a triangle ABC, and with the same base AB I draw another triangle ABD. Okay, this is parallel to this. Then area of triangle ABC will be equal to area of triangle ABD. We need to prove. Very easy. Just look over here. What I'll do, from B, I'll draw a line parallel to AC. Parallel to AC. Suppose AB, MC. BM is parallel to AC. Okay? Then, just look over here. BM is parallel to AC and AB is parallel to CM. This is parallel to this. We know this. So, this is a parallelogram. ABMC. ABMC is a parallelogram. No doubt in that. And area of the triangle, we have already done. Area of triangle ABC will be half area of parallelogram ABMC. ABMC. Done. Now what I do, just look over here. From B, I draw a line parallel to AD. Parallel to AD. So this, suppose AB and D. AB and D. Now AB, see this is parallel to this and DN is parallel to AB. So AB and D is also a parallelogram. Am I clear or not? So area of ABD, area of AB, first of all AB and D is a parallelogram, no doubt in that. And area of triangle ABD ABD is equal to half area of parallelogram ABNC. Yes or no? Now, area of both the parallelograms are equal. Why? Because ABMC and ABND are between the same parallels and same base. So according to the theorem, these two areas are same, which means we can say that area of triangle ABC, if these two are same, can I say that area of triangle ABC and area of triangle ABD are same? Yes, they have to be same. Yes or no? Now let us look at the converse of this. So the converse of this theorem is also true. In fact, we have what we have? Triangles having the same base or equal bases and having equal areas lies between the same parallel lines. Same parallels or same parallel lines. Now, how do we prove this? Suppose we have a triangle ABC and we have another triangle, suppose we have BCD, and the area of both the triangles are same. Area of ABC is equal to area of BCD. They have the same base BC. We need to prove that BC is parallel to AD. Prove that BC is parallel to DA or AD, whatever. How do you prove this? Look over here. From D, drop a perpendicular, suppose H1, DM, okay? And from A, drop a perpendicular H2, suppose AN, on BC. Then area of ABC is half into base into height, which is H2, and area of BCD is again half into base, which is BC, into height, this is DM, which is H2. Yes or no? Half BC cancel, which means H1 equals to H2. Now look carefully. H1 and H2 are perpendiculars on BC, which means H1 and H2, which means DM is equal to AN, and since they are perpendiculars on the same line BC, we can say that DM is parallel to AN. Now, DM is parallel to AN as well as equal, which means DMNA, look carefully, is a parallelogram. And if it's a parallelogram, we can say that MN is parallel to AD, which means BC, because MN is a part of BC. BC is parallel to AD, which we were supposed to prove. Done? Very easy. Based on the above discussions which we just had, we have three results. The first one, triangles on the same base or equal base and having equal area have equal corresponding height. Just now we did now H1 equals to H2, remember? Since the area was same, so half into base into height, area was same, so half into base into height. So half AB cancels out. So H1 equals to H2, which means they have corresponding height. The corresponding height is equal, sorry. Done? Number one. Number two, if two triangles lie between the same parallels having equal altitude, same parallels means the altitudes will be same, definitely. The altitudes will be same. Then the ratio of the areas, if you find the ratio of the areas equals the ratio of the bases. equals the ratio of the bases. Am I clear? If there are two triangles which lie between the same parallels, I'm not saying the bases are same, having equal altitude, the altitude is same since they are between the same parallels, then the ratio of the area equals to the ratio of the bases. So suppose this was A, B, C, this was A, B, D, E. Then area of A, B, C by area of B, D, E ratio will be equal to BC by BD. Done? Then third one, if two triangles have equal bases, then the ratio of the areas equals to the ratio of the altitude. If the bases are same, suppose if two triangles have equal bases, then the ratio of the areas equals the ratio of the altitude. Suppose we have two triangles, look over here, with the same base, okay, but see the altitude is different, okay. So the ratio of these two areas A, B, C, D, suppose the height is h1 and over here we have h2, then area of ABC by area of BCD will be equal to h1 by h2. That is the third result. Done. So these were the theorems, the result, the converse, which will be useful while doing sums from this chapter. So in this video, keep it till here. In the next video, we'll solve sums from theorems on area. Till then, take care and be safe.